A resistor of resistance R, capacitor of capacitance C, and an inductor of inductance Z are connected in parallel to AC power of voltage V naught sin omega t. The maximum current through the resistance is half of the maximum current through the power source. So here we have a resistance, capacitor, and an inductor. RC. Resistance is R. Capacitive reactance is XC. Inductive reactance is XL. Connected in parallel to an AC voltage source of V naught sin of omega t. Right? Let's say the current in R is I1 sin of omega t. This will be in phase with that of the source because it is parallelly connected to the source. Whereas current in the capacitor is I2 sin of omega t plus 90 because current in a capacitor leads the voltage by 90 degrees. And current in the inductor is I3 sin of omega t minus 90 degrees. So if you draw the phasor diagram for the currents, this is IR, this is IL, and this is IC. The net current coming out of the source, let's call it as I will be equals to IR square plus IL minus IC whole square under root. And what it says, this current is equal to 2 times the maximum current of the resistance, that is I1, or in this case it is IR, right? So we can say 2 times of I1 is equal to, basically this is the amplitudes of R, L and C, which is I1 square plus I2 minus I3 whole square under root, which can be written as 3 times of I1 square equals to I2 minus I3. Removing the squares, it is root 3 I1 is modulus of I2 minus I3. That is root 3. What is the value of I1? I1 is amplitude of the source divided by resistance, which is I, is equal to I2 is again amplitude of the source divided by XC minus V naught by XL. So from here V naught gets cancelled. R is equal to root 3 by 1 by XC is omega C minus 1 by omega L under root. That would be optional. We have to be little careful only while drawing the phasor diagram. Once we draw the phasor diagram, the question is quite simple.